In this video, we will introduce how to assemble and use the PCIe to M.2 hat+. Prepare the above accessories. First, connect the solid-state drive and confirm whether it is using the 2230 or 2242 size. If use the 2242 size, just directly connect it. If use the 2230 size, you need to use screws and nuts to fix it. Tight it with the screwdriver. Then use a 2x20 straight-pin header to connect the module. Then connect the 16P cable to the Raspberry Pi 5. Please pay attention to the cable direction. It cannot be recognized if the connection is reversed. Connect the standoffs to the Raspberry Pi 5 and fix them with screws. Then connect the module to the Raspberry Pi 5. Next, tighten the screws. Then connect the other end of the cable to our module. That's it, we've completed the assembly. Now it's time for testing. Connect the assembled device to the serial port. As the Pi 5B's PCIe interface is not enabled by default, we need to enable it. For more details, you can refer to Wiki. Open boot, firmware, config or boot config file. Add DT_perm equals SciX1 at the end of the file. Gen 2 is the default setting. If you need to enable PCIe Gen 3, add. We are not going to add it here. Then, reboot the device. Execute lspci to check the device. Here, we can see two PCIe devices in total. One is a non-volatile storage controller, and the other is an Ethernet controller. The non-volatile storage controller is the NVMe SSD hard drive that we inserted. Executing lsblk shows a disk size of 476 GB, indicating successful recognition. If the user needs to partition the disk, they can execute fdisk to partition it. If only one partition is needed, you can also skip this step. Execute mkfs command to format the device. Then it shows various file formats, and users can select the corresponding file format by themselves. We select extension 4. Specify the device to format. Follow the prompt and enter Y, then wait until Done appears, indicating that the formatting is complete. Next, mount the device by creating a mount directory and using the mount command. If prompted that stab has been modified, you can ignore it. Check the disk by executing dfh. You can see the NVMe device mounted to the directory you just created. Enter the directory where the disk is mounted. Then clear the cache. Use the dd command to test the disk write speed and wait a moment. During the read-write process, you can see the ACT indicator blinking. You should observe the writing speed of 495 megabytes per second. Next, conduct a read test and try to perform the test several times. Please note that the speed may be affected by caching. Data might be cached from memory, resulting in faster than expected results. Since we need to boot from NVMe, we need to program the system to NVMe. First, install the programming tool sudo apt install RPI imager. Open VNC and log in or connect via HDMI to access the desktop. Here, we'll choose to log in via VNC. First, use sudo raspi-config to open VNC and connect the local VNC client to Pi 5. Open the programming tool. Select Pi 5. Select the image. Select the disk and then Next. Set the username and password and set the language environment. Open SSH. And then save. Input the password as required. Modify the Raspberry Pi 5 command sudo rpie promcong edit. Modify boot order equals 0xf41 to boot order equals 0xf416. 6 is NVMe booting, 1 is booting SD card, 4 is booting USB, and F is the cycle. 416 means booting NVMe first. If NVMe boot is not available, then boot from the SD card. If neither NVMe nor SD card boot is available, then boot from USB. Repeat the recognition process until the system is found. After restarting, execute DFH. You should see that the root directory is now located in the NVMe directory, indicating successful configuration. For power monitoring using I2C control, first, enable I2C. Execute raspiconfig. Select Interface. Select I2C, choose Yes, then exit. Download the demo. Unzip the demo. Navigate to the demo directory. Execute sudo python -m.219.py and you should be able to see the device's operating power.